Okay, hi everyone, and welcome to CG Buildup. And today we're going to be starting this first part series of this motion along the spline. This is the first part. We'll be making the curvature of the spline where the chains will be moving. So without any further ado, let's begin. So I'll have these items here, which I will share in a blend file, where we got the rings, the distance line, some two chains, this one here and the one in the middle that will be connecting, and after that you'll be able to follow along, and I will share this blend file with you. Hopefully you'll be able to follow along. So by starting, I'll just hide them for now. I'll click the collection, and I'll just add in a plane mesh, and this plane mesh, I'll just call it the system itself. Everything that will be encompassing these chains, some other stuffs including empties. So for example, I'm going to add in an empty plane axis, and I'm just going to add it, keep it there, then duplicate it to somewhere there. Actually, these two empties, I'm going to move them to a new collection, which is going to be called structure control. Structure control, which will be controlling the structure of the whole system, and we'll be seeing that soon. And to make it more interesting, I'm going to just scale one of the empties to be bigger than the other one, and that's all you're going to be needing in this tool. So I'm going to click this system, go to the geometry node workspace, reduce the spreadsheet. I'm going to look from above, and I'm just going to click this system, pin this, but before pinning, let me just click new, change it to motion, change the name to motion along the spline, just like that. And then I can pin this, and I also prefer to pin over here as well. And actually won't be needing the group input, rather we're going to start by this structure control. I'm going to keep it here, set it to relative, separate children because we need more than one instance, and just like that. Now I can just mute that there. Then I'm going to convert these instances to point to instance, to point, like there. And I want, no matter where the empties are going to be, the resulting points will always be flat on the Z, meaning that they don't have any value, either greater than or less than 0. So I'm going to add in a set position node, and I'm going to multiply the position by 1 in the X and the Y. And we might not be seeing them for some time, but if I just instance on points, okay, and our instances will be mesh cycles, just like this, mesh cycle, like that, and you can clearly see there are two of them here. Now what I want these mesh cycles to have is that they should adapt to the scale of these original instances from this collection. So what I'm going to actually do right now is add in a capture attribute node, connect it there, and here I'm going to add in an instance scale, connect the scale to there, and connect this one to the scale in this resulting instance. And actually, instead of being point, because the original instances, keep it to instances, and there we go. They are sort of mimicking the original. So if I see, if I select this empty, increase it in a way, we can see something starting to happen. Okay, so that's the concept. So the next step is I'm just going to realize these instances like that, and I'm going to now sort of do a convex hull, and add in a convex hull. Here it is. If I go here, I get something like this, which looks pretty cool, but I normally like to prefer to do it this way. I give this some circles some thickness first, whereby I'm going to extrude this mesh, and I'm going to extrude the edges, and the offset I'm going to connect in a vector, and type in one there and connect it there, and now it will have a little bit of thickness, and just like that. And the good part is, if I grab one of the empties and grab it not so high, it will still be flat, rather than if I could allow that even if I accidentally do this, something to happen. If I like mute this flattening thing, I mute it, it forms this structure, which won't be actually good in the calculations, because I mean actually the forming of these chains along that spline, because normally these chains, for example in water tanks and uh in bicycles or some machinery parts, especially in the industry, they're normally in a flat, fairly flat surface, I can assume. So that's why I need to flatten them like this, and it's good. And what we can do now is separate the face at the bottom. I prefer this way more than not doing this completely. Then so what I'm going to do right now is just on adding an attribute statistic node and set this one to faces, this one set them to Z, and connecting the position, and I want to say which face has the minimum Z position, and that face is the one that we're going to be separating using the separate geometry node. Connect it there, set it to face, and here we go, the flat face that we were in need of. And we actually don't need the face at the moment, so we're going to add in a delete geometry node, and we're going to set it to face and only faces. And if you connect there, we can see we get something quite beautiful, right? Let me just flatten out this empty, and we can see if I duplicate this like shift D, go somewhere here, we still get the structure, right? Anything that is in the middle won't contribute to the structure unless it, you know, its size sort of touches outside, and something like that, cool stuff. But let me just keep it fairly simple, and I don't really like seeing the cursor normally when I'm doing geometry nodes, so remove that cursor. So the next step will be converting this to a curve, and for what we're going to do, actually, we really need to control where the end point and the start point of a curve are going to be, because we're going to use the trimming of a curve to form that animation, and we're going to actually need to control the motion later, and we really need to know where the end point is always going to be. So this is how we're going to do it. So I'm just going to grab this group output there, and I'm going to here connect an attribute statistic node again, and this time we're going to ask from the point which point has the highest position along the x. Okay, and I'm going to connect equal to and connect it here just like that. and in most cases we can only get one point that has the highest value of in the x position, but sometimes they can be two. So I prefer normally to do like an accumulate field node, and we connect this result to the group ID and say which one in the trailing has equal to 0, so that always only one is chosen. And we connect this initial result, and just like that. And what we're going to do is we're going to save this boolean, and we'll see why. So I'm going to add in a capture and something like that. Connect this boolean here. I like how we don't have to change whether to point, then later we just change to the attribute to it. It's really cool that they have this socket here. So what next is we're going to extrude. Okay, extrude mesh. There we go. We're going to extrude the edges. It looks awkward, doesn't matter at all. What we're going to add in next is a split edges, and we're going to split this origin one here to there, just like that. Then afterwards we're going to delete geometry, and we're going to delete the top, and in so doing, and let's just convert this into a curve, then we add in a trim, and we connect it here, and in so doing we have made the endpoint to be and the start point to be somewhere here in the start. That's why if we start trimming, we can see there's a point over here where we start trimming again, going this way. And this trimming here is what we're going to use for the whole animation, and this is actually going to be really useful throughout. So let me just give it some room here. I'm going to talk about why am I giving it some room here a little bit in the end, but let's just focus on the animation using this spline. And we're going to be using rather this length factor than the factor, because we want to keep speed, and later we'll have to add the wheels, and we want the speed to also control the chain movement, also using the same speed parameter to control the wheels. It makes it easier, so that in the end we get a more realistic motion. Okay, so and I'm going to duplicate these two, and I'm going to shift control D. Here I'm going to connect a reroute, and here if I connect it here to the start, then in the one at the bottom I have to connect it to the end, and here in the end, in the one that I connected to the start, I should make sure its end here reads the spline length, and just like that. Okay, and I'm going to join these two. Actually, let me first just show you something. If I connect in here a value node like this, and just start trimming here, we can see a certain portion of here has been trimmed already. But if you go at the bottom, okay, we can see that portion that has disappeared on top is the one that has reappeared here. So if we join these two splines here by merging this point at this point here, we can sort of form a spline whereby its endpoint, okay, like this one here, is sort of moving, okay, with time. And that is going to be very essential later on, when we are going to be trying to sort of trying to make that motion of the spline and sort of the chains, whatever, That's going to be very important because later we will resample it. It's going to be more realistic, as in it will look as if there's chain, sort of chain movement happening. So let me just show you. So what I'm going to do right now is just add in a join geometry to join these two splines here, and in here I'm just going to add in a map range node. Okay, so in this value here I'm going to add in a scene time, and I'm going to connect seconds, not frames, whereby 0 0, but when 1 second passed, how much along the spline will be trimmed, that is like saying speed. So in here to min, I'm going to connect in the group input just like that, and I'm going to rename it, and I'm going to call it speed like that. Okay, then I'm going to sort of make sure it's not clamped. That's going to be very important. And in the result here, I'm going to modulate it, flow modulate it, and we're going to sort of flow modulating using this spline length. So I'm going to just duplicate it here and connect it to somewhere there, and connect this to there, where it's going to be fed into the start and the end for the bottom. Now if I play this, okay, there's nothing happening, like we can't see anything happening, but actually in here there are two endpoints that are keep moving along this sort of spline that we're seeing, although they're actually two. So we're going to make it one spline, but its endpoint, it keeps moving with time, and we'll see to it. So to make that possible, okay, we're going to sort of capture two attributes here and here. So I'm going to capture an attribute here. For here, I'm going to capture the endpoint. Here, I'm going to connect the actually for the top, since we're not trimming the end, okay, the one which is moving the start, so we have to actually capture the end, not the start here. And for the bottom one, we're going to also do the same, but because we not trim the start, that is what we're going to be capturing. So endpoint selection, capture the start, and we're good to go there. And what we are going to do next is convert this into a mesh, just to merge it by distance like that. And if you leave it like this, then the work done will be, let's just say 0, because not only the endpoints that are going to be merged are not the ones we intended, so we actually have to connect to say that this should either have this attribute or this attribute in order to be merged. And it's going to be like this, and connect there. And now if we sort of convert this to a curve, mesh to curve, and maybe we can do something like instance on points, connect it to the group output. In the instance, connecting some icosphere, and maybe here we can type it 0.1, and if we play, we can see there's this icosphere that keeps moving with time, and actually something feels wrong because the speed is actually 0, is supposed to be written at least 1. Yeah, so let's check what's happened here at the back. Yes, instead of connecting to the 2 min, I was supposed to connect to the 2 max, meaning 0, write 0, but for 1 write the speed. So sorry for mistake that I made here. It's at this point before we trimmed. So what I'm going to continue doing is play, and you can see there's this point here that keeps moving with time, right? It keeps moving with time, and we can go and make it even faster, maybe typing 10 so that it actually completes the loop, and we can see it's moving like that. See, keeps going and going. But this is not the motion of a chain. The short magic in order to make it to look like the motion of a chain is very simple. It's just to resample this whole thing. Just resample it, even by 10, by whatever number that you are. Let me just write 20, and now if I play this, you can clearly see what's happening. Maybe now turn it down a bit. You can clearly see now what's happening. These icospheres are moving as if they have a certain chain motion. See, you can see like we're done with this, right? But actually it doesn't feel like we are. Let me show you why. See, right now it's moving in this direction here. Okay, if I play this, you can clearly see what's happening. It's moving in that direction. So if I go back to the layout and just play, if I grab this one and move it to somewhere here, you can clearly see now it has gone back to this anti-clockwise direction. This flight, if I move it here, it's going clockwise, anti-clockwise. You know, it gets annoying if you just leave it at here. It gets quite annoying. You just want it to move in one direction to choose, not that when you move somewhere it goes changes the direction. So what we're going to do right now is make sure it is we choose either by at default it's anti-clockwise or clockwise. Okay, and it only changes to clockwise or anti in another direction. Like for example, if we set it to clockwise, it only goes anti-clockwise if we type in a negative value in the speed. That is what we actually want. So how we are going to control that is going to be very simple. So what we're going to do here, go to the geometry node section, and remember this space here I said that we're going to leave. Actually, I already made it congested here at the bottom. Let me just move this here. This place is what we're going to deal with right now. So I'm just going to move these ones to the side, just like that. And what we're going to do right now is very simple. We're just going to add in a switch. And that switch is going to sort of reverse everything if things go not the way that we want. And how is it going to know that it doesn't go in the way that we want? That's also very simple to guess. So we're going to add in an evaluate node, and evaluate at index like that, and we're going to evaluate the position along the y. This 0 is the position of the start along the y, and we're going to connect in here the position, and we're going to add another one of the same kind but along the one. Now if we want it to go always in a clockwise direction, I believe we should always make sure that if this value here becomes less than, actually if this value here becomes sort of less than, I believe, than this, if not greater than, it's one of them, then it should be reversed. But if I connect it here, this is what happens. So it needs a cycle here, and I didn't know what to do than this method whereby I connecting a sample index, and then I connect this value, can change it to boolean to there, then I connect this one to the switch, and right now if I play, it goes in this let's say clockwise direction. But if I type in here -5, and it now goes in a negative, in an anti-clockwise direction, and this is essentially what we actually want. And before so this is where I actually have to end in here. But before we go on, I think I have to make it a little bit smoother, and the best way to do that I found out is actually before the resampling. Actually, like, I want you to not actually, just set this one to be a Bezier curve. So set it to Bezier, which is set spline type to a Bezier. Then set the handle to be auto and connect it to there. Actually, also set the spline resolution to be something like even 30. That can be okay. And connect it here. The higher the better, actually, for smoother. And there, we play this, we get this sort of chain motion that you're seeing here. These icospheres moving. And yeah, I think that's the end of this first part of the tutorial series. I hope to see you in the next one. Thank you. If you like the video, subscribe, click the like button, comment, and see you on the next one. Okay, welcome back everyone to the second part tutorial of this motion our splines, where last time we were making the pathway and showing you generally how the motion is again, how we are going to actually make the objects move along this path. And this one we're just really going to add the chains. And if you haven't watched the previous, I really recommend that you watch the previous part. It's going to really be helpful to really understand what's going on right now. So we ended up here where I did the icospheres and did the resampling and stuff. So what I'm going to actually do right now is actually delete this part because it was only for demonstration. I'm just going to press Ctrl X, and instead of resampling by count, which is actually better but not actually good as well. So what I'm actually going to do right now, I'm going to set it to length, and this is going to be the length of the chains. So I'm just going to connect this to input, and I'm just going to change this to maybe chain size. Yeah, they're going to be the sizes of the chains. This value is going to determine it. And I'm going to like to print 0.4. I feel it's going to be a little bit better. So what I'm going to do right now is convert this into a mesh, curve to mesh, something like that. And I'm going to sort of duplicate the edges. Okay, so each edge is its own, right? Something like that. And what I'm going to do right now is separate geometry, and I'm going to separate the edges. And how am I going to separate them? It's like a certain module, sort of like even cutting, like a certain pattern that is going to be made. I'm going to mute this structure control. So what I'm going to do right now, I'm going to connect the equals to 0, and here is going to be a float. Here I'm going to connect the math modulated, and we're going to modulate the index. Okay, and we're going to modulate by 2, so the index of these edges will be going, instead of going 0 1 2 and so on, it's going to go 0 1, and then starts repeating again when it reaches 2, going 0 1 0 1 0 1 0 1. And at this first point I'm just going to select 0. You can select 1 if you want, doesn't really matter. At this point you can type in 1 here, or 0, leave it like me. So I'm going to connect this into the output, and you can see sort of this even even thing that is happening right now. And if I play it, you can sort of see as if the edges are moving, okay, sort of evenness here, except one which is over here, and I will explain why. And that's the reason why here, it's because of here. So I want to do this later. I think I prefer to do this later, to demonstrate later in the end. So I'm just going to leave a little bit of space here, okay, and I'm just going to grab this somewhere there and somewhere there, just like that. So what I'm going to do right now, we're going to start instancing, okay, and I'm going to start by adding an instance on points like that. And what we're going to instance is an object info, which is one of these items over here, which are these chains, which I named them as chain 1 and chain 2. In the first case, I'll instant chain 1, and in this case I really uh, tell you to keep it at original. I know we normally add the object info node, set it to relative. I did this before, and you don't want to do that. Just keep it at original and connect it to there like that. Let me just hide the items now, and now it looks messy. You know, everything is overlapping and it just doesn't give the chain vibes. So first of all, I want to point out something. We need to instance on one of the vertices in every edge. We don't want to instance on every point, but one vertex in every edge. And the right not to do it, in my previous references, was the edges vertices. So I'm going to add in the edge vertices, which is this one here, and I'm going to connect in here the evaluate domain like that, and this is going to be the domain of the edges, so the information also goes to the points in the end of the day. So I'm going to connect in equal, and B I'm going to connect in the index, and hopefully by doing this I'll have decreased the number of points, and it still doesn't give us those chain vibes, like this thing is a chain whatever. So what we're actually going to do right now is to scale them down a bit. Now by how much are we going to scale? That's the question. Okay, so if we actually open this and maybe map the system, is that this chain has a distance from here to here in the cycles, and that's why I kept the origin. For example, each chain like this one here, its origin is over here, it's this one's origin over here. Even actually the distance, the origin is in the middle, and the origin for the distance doesn't really matter. This distance line here, this distance line is the one that I wanted to use instead of going all complicated and stuff, and just wanted to make it simple. I just wanted that distance line to tell me the distance between those 2 points instead of finding it myself. Could make it a little bit complicated. So I just actually modeled this, and this cycle that is formed here by chain 1, this one here, the distance between these 2 cycles is between the same is this line here, and it's the same for this one here. It should be the same, and the origin position to be one of the cycles is also very important in this case. So what are we going to do next is scale them down. Now I'm going to open to see now the system, hiding the items, and there is how we're going to scale everything. So I'm going to duplicate this here. Maybe this one I can change it to relative and keep the distance line. So we're going to do a sample index, and we're going to do sample index of every edge, and here the value will be the distance. And actually we can duplicate this one here, and we're going to do like the distance of these two, then connect it to the value like that. Then we're going to actually divide, okay, and we're going to keep this actually below here, and when it comes to the one on top, it's actually the same, okay, like the original size. Like for example, um in this case, if we're instancing on this point, we want the chain to be from here, let me just write from here all the way to here. So we actually need to sort of divide the the original size, okay, then multiply by the size of the actual edge. That's why this come in. If we keep it here below, it's like we're actually dividing, then we keep it here, it's like we sort of multiply. It's sort of complicated, but this is how it's done, okay. It sounds complicated. Then here I'm just going to click in the evaluate domain, and this is the domain of edges, because remember it's edge vertices, this information is mostly in edges, and connect it here in the divide. Then I'm going to connect it into the scale. So hopefully by doing that, if I connect theirs there, and now it's giving those chain vibes, right? Like the sign, and you can even assume like this version, it almost looks like an escalator. Okay, it almost looks like an escalator. It doesn't look like an escalator, but it does give some escalator vibes, especially this portion over here. Yeah. So what I'm going to do right now is simply now orient them to be in the right direction. So what we're going to do now is align the rotation, we can say. So the simple, if it's that method, it's actually quite simple to do. It's the same these edge vertices, connect this one, duplicate them somewhere there, send it to subtract, and because here we chose to instance on the first one, index 1, we'll actually have to subtract position 2 from position 1, like that, not the other way around. Then we're going to connect this to the align rotation to vector, and we're actually going to connect this to the vector, and here we're going to like choose the X, because if you these things, the chains are flat, actually not flat, but this, it's along the X, this distance line, and how they're oriented is along the X, and there. And hopefully if I connect this rotation into the rotation there, okay, didn't go as planned. It's because I changed it, instead of writing subtract I kept multiply. And now if I keep it to subtract, now if I play this, it's almost giving those chain vibes that we actually want. You know, everything seems to be all right. Okay, it gives that chain vibe except over here, and I'm actually glad this happened. And this will, I will explain later in a minute why this happened, whereby every chain, you know, it's all by itself, but here is where we get an intersection. It's actually because of the system of resolution that we kept there, whereby we were resampling by length and not count, and I'll show you why. Okay, so for the other part, because we actually finished with this chain one, for the other part it's actually the same, it's the same thing, but the only thing that we have to change is the chain, as far as I remember. So shift A, connect this to the join geometry, grab it somewhere there. Now we're taking this and this, grab it to somewhere on the top, then press Shift Control D, move it down. Now instead of this, the inverted, the selected, keep the inverted. Instead of here in chain 1, when instancing, keep chain 2, make sure it's in original. Doing this true by join geometry node. Keep it there. I can delete this one by Control X, Shift Alt. Make sure you enable node wrangler. And now if I play this, you can see that chains join together, feeling that it's coming now, right? So we still have this problem here. We have this part here that's intersecting, and it's kind of uncomfortable watching if it keeps playing, and we have this small part. So how to solve this is actually by resampling. Instead of by length, you resample by count, right? And that count is always supposed to be an odd number, whereby if you write an odd number, no problem happens. And even, there is a problem. Odd, see, that's what's happening. So we can say that we change this, instead of chain size, to be number of chains. It's okay for some people, but for me it's not. I prefer the size of the chains to remain always the same, no matter the case. Okay, so what we're going to do is we're going to resample by count, I mean by length, but the way that the number of points that's going to come out here, we're going to sort of add 1 whenever we get an even number. So what we're going to do is very simple. We're going to connect this to a resample curve by count and connect it there, and now they are 10. So what we're going to do right now, we're going to do a sample index, and we're going to do of a spline, and we're going to connect it to, set it to integer, and this we're going to do a spline count. Spline length, we're going to do point count, connect this one here to there, and we get back our original. So, but we have this problem here, that is always, there's always a hole. So what we're going to do is actually we're going to multiply this. Actually, we're going to divide this by 2. Okay, something like that. And we're going to take the fraction from here. For example, in this case of ours, the value is 0. Okay, if it could be a different number, if it could be equal to, let's say what, 0.5, because in some cases, for example, if I write 0.3, maybe it's going to be 0.5. Some number is going to be 0.4, depending on it's going to be even or odd. So we want that if it's always equal to 0, okay, add 1 to whatever number, whatever amount of points that we're going to get from here. So I'm going to write in here, add 1, but under a condition that it's actually equal to 0 in this procedure, because if it's equal to 0 means it's even, if it's equal to 0.5 means it's odd. Okay, so simple like that. I'm going to connect this one here, select all this, grab them somewhere there. So I'm going to connect this one to a switch if it's equal to 0, and connect this one. Actually, I have to change this to an integer and check this one to be there in the false, then this one to be in the condition, and keep this one there in the count. And hopefully if I mute this one, Ctrl X, maybe I should switch. and take this one somewhere there. Okay, something seems not to be right. Okay, I get it now. We are right at the first time. The thing is, instead of adding 0.5, it should be added 1. And now, if I look from the top and, and maybe select this and maybe write 0.6, no matter the and play this, no matter the number that I write here, maybe I can write 0.7. There will never be a hole, okay, unless you want it yourself. And yeah, simple like that. Now we have some chains moving, and I can increase the speed as usual, give it to 4. I don't like that it's moving in the clockwise direction. Change it to -4. Yes, now it's moving anti-clockwise. It's moving too fast. -1, like that. Simple as it is. And that will be the end of this part, because actually, because everything is now done. The only thing is that we need to add the wheels, so that these things to be seen as if they are controlled by something else, like the wheels are the one that is controlling this thing. So yeah, let me see you in the other part, which is the last part, will be part 3. Hopefully you'll join me in this series, as we're going to be adding the wheels. If you like what you're seeing, please consider liking, subscribing, commenting what you want to see in the future, to try out, and thank you for watching till here. Have a nice day. Hi everyone, and welcome to CG Buildup, and where today we'll be finalizing the motion along spline tutorial series, whereby the first one we made the pathway, the second we added the chains, and this one is going to be quite short. It's going to just be adding the wheels, or the spline, or the rings, which we can say that is controlling these chains moving, so that is sort of mimic that control. You can call it whatever, wheels or rings. And I think if you're enjoying this series tutorials, please feel free to like, subscribe if you're new, comment your thoughts, and uh, tell me what you wish to see in the future, that you think I could check it out and maybe see if I could help out when it comes to geometry. So how are we going to add the rings? So first of all, this is the most important thing to consider. My rings that I made here, which I shared the blend file with, actually made of, has this ring here which I named it. If I just hide the others, this one here, if you check the dimension, it's a cycle. You check the dimension, it's 2 meter by 2 meter, especially in the X and Y, the important dimensions. It's 2 meter by 2 meter, meaning that it has a diameter of, a radius of 1, which is going to be very important when making these wheels right now. So I'm going to also hide this, collapse this there. So let me just reduce the spreadsheet window. So what I'm going to do now, click this one here, and remember this part when we added the cycles at first, the very first moment here, okay, like this one here. We're actually going to do the same, but this time I'm going to use the mesh cycles. Okay, I'm just going to move it there up, and in this items place, in the place of the rings, I'm going to move it, add in an object info node, and connect this geometry node to the instance, and see how it looks like. And there we go. And I would prefer to look it from the end view, whereby I'll move it to somewhere here, maybe add in a reroute somewhere there. I don't prefer to connect it directly there, but I prefer it to be connected to another one. And Control X on that. Now if I press play, we can see the chains are moving, but not the wheels. So what we're going to do is simply rotate these wheels. And I'm going to add in a rotate instances. And here we go, add in one. And there we go. Now, how much angle are we going to be turning? And it's going to be along this Z here. We're going to be turning. Well, so it's supposed to be depending on the speed of these chains. Now, I want to remind some of you who have ever heard of this before. The velocity, or we can just say speed, for some people to understand, is equals to, if you ever heard of this before, called angular velocity times radius. And this angular velocity, let the name not scare anyone. It's simply the number, the angle. Okay, this is going to be the sign of the angle turned per second. You know, this, how much are we going to turn this angle here along this Z per second? Okay, which is going to be velocity. Okay, if you divide this with the radius, this velocity is just speed. Let's just call it speed. Okay, which we already have it here. And the radius in our case is always going to be equal to 1. Okay, this cycle's initial is going to be equal to 1. The only thing that is going to change is the scale of this empty here, which we started with originally. So what we are going to actually do is take the velocity. Okay, so I'm just going to add in a math node, and in this we're going to change it to divide. Here we're going to connect in this speed parameter. Okay, this speed parameter from the group input, we're going to divide by the scale. Okay, and that scale is comes from here, that remember we captured before until we connected there. Just going to add in a reroute there and divide it there. And here, for as we did for the speed, where we did a map range and we did not clamp, and we said when it is 0, it's going to be 0. And actually this is going to be in the 2 marks, whereby for 1 second this is what is going to be turned, and here in the value we're going to connect in the seconds for the scene time, and in the results here we're going to add in a combined XYZ and connect it into the rotation, and we can see a certain small movement happened here on top. And let's see what happens if I play. So it's actually moving in the same speed, but it's like opposite from this the original that the chains that were made before. So in order to change correct that, we only need to multiply this by -1 and connect it to the Z, and you can see now everything is aligning correctly. Well, let's say just mostly everything is aligning correctly, and you can see clearly here there's something, right? Something is actually happening throughout here. Let me just take these keyframes that were actually made here by the drawing tool to be deleted, and we can clearly see what's happening right now. The wheels are rotating and the chains are moving in the way that you would expect in machine parts too. We can now look at the structure control. We can click this empty, move it there, move it there. We can duplicate this to move it to any part that we want, and the chains will relatively remain the same size. Okay, see, this is what I was actually talking about, and this is the concept that I wanted to bring home to you guys, and I hope you found this tutorial series helpful and help you to build other cool stuff using geometry nodes, adding to the knowledge, sharing with one another. And if you found this very helpful, please consider liking, subscribing, for the YouTube algorithm to know that there is a channel like me out there. So thank you for watching all the tutorial series till here. Have a good one. See you on the next one.